Cedar was keeping about 20 beehives, and at that level of beekeeping you don't have any machinery to help you lift the heavy boxes. It's a subtropical area we live in. It's hot and sweaty in the summer. The sweat wets your bee suit and the bees just sting straight through it. So one evening after a day of hard work and getting stung and the frustrations of lugging all of this heavy gear into the honey processing shed, Cedar said to me, "Dad, we've got to figure out a better way to do this. We've got to figure out a way to get honey out of a beehive without opening it." And I thought, nah, that's impossible.
Hi, I'm Cedar Anderson.
My name's Stu, and I'm Cedar's father.
And together we invented the Flow Hive. So the initial problem we were trying to solve is how do we harvest the honey in a way that's both gentle on the bees without disturbing them, and a lot easier for the beekeeper in terms of not having to go through that long, labour-intensive process of getting in your bee suit, getting out your smoker, pulling apart the hive, taking those frames to a processing shed, using a leaf blower or a brush to brush off all those bees, cutting the wax capping off the frames, spinning those frames in a centrifuge, filtering out all the wax and bee bits, cleaning up all the mess. If that's not enough hard work, those frames have to go back to the hives again. So a lot of hard work to get your honey, and I thought there has to be an easier way. There has to be a better way where we can drain the honey straight out of the hive into your jar without opening it, without disturbing the bees.
Our quest to get honey out of a beehive was going to be impossible. Perhaps some of you know what a filing cabinet looks like. It's got all these files hanging in a drawer, each individual, and you can open and close the drawer, open the drawer and you get the file out. Well, what if I closed the door and locked it and said, now get a file out? That's the problem we were facing.
So the design objective was to get the honey out of the hive without opening it, without disturbing the bees, and making sure that it was a gentle process so the bees could go about doing their business as we could watch the honey drain into your jar. Now that led to a whole bunch of problems to solve. One of them was, how do you get honey out of a hexagon cell? So the bees make their beautiful hexagon pattern, and if you cut the capping off and you turn it over, and the capping's the wax sheet the bees put over the honey when they've reduced the water content down enough. If you cut that off, the honey still doesn't drain out. If you cut the backing off it as well, it still doesn't drain out, even if you tip it over on its side. So we tried all sorts of things. We tried to push out the honey with piston plungers. We tried to suck it out. We tried to make complex things inside the hive where capping moved away and the back moved away and the hive was on a tilt. And we failed, and we failed, and we failed. So one morning I woke up and I thought, hang on a second, it doesn't have to be hexagon cells all the time. It could be a hexagon matrix when the bees are filling it with nectar and doing their process of making honey, and then change and pull apart into something else when it's time to drain the honey out. So I quickly got my pencil and I started scribbling things, and I wasn't even out of bed yet. So I set about making this complex prototype, which had the use of an old car tyre tube and a suction diaphragm, and I would painstakingly cut with a craft knife all night to create a structure for the bees to then fill with honey. And while I was getting somewhere and it was starting to show promise of working, my father, after a few strong coffees, went, hang on a second, how come we're going this way? How about we go this way? And I suddenly knew exactly what he was talking about. Rushed into the shed and we started to make a brand new prototype, scrapping years and years of work. So from there, we got some parts 3D printed, and that cost a lot. It was $2,000 for a very small area in the quality we wanted. And that was $2,000 that we didn't have. So how do we get from there to not only film one box full of our flow frames, but multiple boxes in our own apiary and around the world to make sure we're going to test it thoroughly? So that meant we had to start injection moulding.
When we took our first prototypes and our hand drawings to the engineer to get them drawn up properly, and we said, we want to injection mould this, he just laughed at us. He said, a mould to make this is going to cost you $500,000 or more. And we went, whoa, we were pretty poor at the time. And so just at that moment, leave the engineer's office, back to the drawing board. How are we going to solve that problem of to make a large mould, intricate mould is very, very expensive. And we realised, our frame actually is repetitive. It has the same pattern all the way through. We can make it in segments that all fit together. And that then had a whole lot of other advantages in that you could make it different lengths, because all around the world people's beehives are different sizes. So suddenly it was adaptable to different size boxes. Creativity doesn't stop just when you've solved the main problem. There was endless little problems for us to solve, and sometimes the solution that came out of solving those problems was even better than we imagined. So for example, we had the main frame and how it worked with the moving bits of honeycomb and so on, but it needed to be held by two end pieces. And Cedar thought, well, what if they were clear? And I thought, yeah, well, maybe they could join together to make a window. And then you could sort of see into the hive. I thought, well, yeah, that's a good idea, let's do that. And that was like an accidental part of the design in a way. It was just, and there were lots and lots of those.
So a moment I'll always remember is being there in the paddock. We've got our prototype in the hive and we've got a spanner on the outside of the beehive and we're turning it and honey just started pouring out into the jar. And we're there going, amazing, it's working for the first time. And watching the honey just fill the jar was incredible. It's certainly, after such a long time of trying and failing and trying and failing, it's a extremely memorable moment to see it work for the first time. So then we thought, we have the invention working, and now it's time to take it to market, make it a part of the world. But we wanted to make sure the way we were doing that was doing the right thing for our planet, for our bees. So we went on another whole design loop, making sure that bees, if they're down moving cells, can't get legs or wings caught. Some people might not consider those things, but for us that was really important, that it was going to be great for the bees and also something that is going to inspire people in the world to take up beekeeping and look after the amazing little insects that make our world go round. So here we are, 5.5 years on, and we're so lucky to have a community all around the world. We have 75,000 orders, people using Flow Hives in 130 different countries and enjoying harvesting honey and looking after bees in this new way. So then of course there's constant refining that needs to happen from feedback from those that are using the product. So with our Flow Hive 2, one of the problems we wanted to solve was make it easier for the beekeepers to get the hive on the right tilt to harvest your honey. So we put levels in the side of the hive and we put adjustable legs on each corner. Then we improved the baseboard by putting a pest management tray that you can catch hive beetles in, or you can count your varroa mites. We also found that the wooden knobs after a while would tend to break off. So we changed to quality brass fixtures. We also found that when we get a wind of about 80 kilometres an hour coming up the slope here, the roofs of the hives would blow off. So we created these little wing screws that hold the roof onto the hive. So the job of innovating is never finished. There's continual improvement, and since the beginning we've made hundreds of small changes to continually make our product better.
You know, one of the criticisms of the Flow Hive is that we've made beekeeping look too easy, and it's important to remember you still need, as a beekeeper, to look after the health of your bees. It's really, really important. And to do that you have to open the hive and you have to get used to having your hands in there. Now you can see me smiling because I love having the bees crawling all over my hands. It's a wonderful feeling. But it's scary for the beginners. So one of the innovations we're working on is to make that process easier, to get into the parts of the hive that you need to inspect more easily than you can at the moment.
So every product that gets made and every company that makes them has an impact on our world. And we want to make sure that our impact is as positive as it can be. So we're constantly looking at our materials and saying, how can we do better? How can we choose materials that are better for our world? So we're testing bioplastics, we're testing recycled plastics, we're testing recycled wood fibre. In the end, it's our goal to get to a completely sustainable product.